Welcome to lecture 27. In this lecture, we will continue our discussion with a numerical that we are solving for a open circuit and short circuit test. Now, this is numerical 8.1 from the book of Nagarath and Kothari. What we have done in this is that we have used the open circuit and short circuit data, and from there we have calculated excess value of unsaturated synchronous reactance, that is 8.21 ohms. We have calculated the saturated value of synchronous reactance, that is 7.7 ohms, and we have also calculated the short circuit ratio, that was 1.64. You may revisit the previous lecture to recap what we have done and how we have calculated this. Now, the fourth part of the question was to determine the excitation voltage needed to give rated voltage at full load 0.8 power factor lagging using adjusted synchronous reactance. Now, here the rating of the machine is 1 MVA and the rated voltage is 3.6 kV. So from these two information we can find the value of the current. So how we will do that? We will write like this: root 3 VL IL is equal to 1 into 10 to the power 6. So IL is equal to 1 into 10 to the power 6 divided by root 3 into 3.6 into 10 to the power 3. If you calculate this, this comes to be 160.37 amperes. Now we have to calculate the excitation EMF. How we can do? E of F, we know this, is equal to, we will write like this: E of F at an angle delta is equal to V at an angle 0 plus IA at an angle phi into XS at an angle of 90 degree. We have to find E of F. So here we will substitute 3.6 into 10 to the power 3 divided by root 3. Why root 3? Because you will convert everything to per phase when we will calculate. So this is line value. We will calculate it to the phase value. The phase value is this divided by root 3. Now this is star connected machine, so line current is equal to phase current. So here we will put 160.37 at an angle of minus 36.86. From where we got this? It is mentioned that the power factor is 0.8, so cos inverse 0.8 is 36.86, and lagging, that's why minus, into XS. What is the value of XS? It has been said use adjusted synchronous reactance, so we'll use this value. This is 7.7 in at an angle of 90 degree. So if you evaluate this, this comes to be 2987 at an angle of 19.31. Now this is phase value. Since we have put all the values here, this is phase value, this is phase value, so this is also phase value. So what is the EF line to line? It will be 2987 into root 3. So that will be 5174 volts. This is also volts. So this is my induced EMF. So next part of the question is to find the regulation. How we find voltage regulation? We write voltage regulation is equal to E of F, of course magnitude, minus V of t terminal voltage, again magnitude, divided by terminal voltage. This is in per unit. If you multiply it by 100, it will become percentage. So this is 5174 minus 3600 divided by 3600 into 100. That turns out to be 43.7%. So this is one of the way of finding the regulation. But I will say that this is not the correct one or the best one to find the regulation. Why I am not saying that this is not wrong or this is correct? The reason is that these are all approximations, and some approximation can be good, some approximation can be bad. But we cannot say that this is a wrong approximation. This is an approximation what we have done, but this approximation is not very good. Let's see why it is not a very good approximation. Now, when we have used this equation, we have assumed Xs to remain constant at 7.7 ohms. When we have evaluated this equation, what we have assumed? We have assumed Xs to remain constant at 7.7. What does this mean in this graph? In this graph, it means that my synchronous reactance is constant. That is, we are assuming that the characteristics of the machine is along this straight line. So this is my modified air gap line. So if we assume that Xs is constant at 7.7 ohms, it means that we are assuming the characteristics of the machine to be along the red line. So this is my terminal voltage, and as per our calculation, this is the no load voltage. Now the thing is that the actual characteristics of the machine is not like this, but it is along this line. This is the actual characteristics of the machine. So it will be better if we can take care of this curve, or if we evaluate the performance of the machine along this curve, it will be more accurate. So how to do that? Corresponding to this point on this red line, that is, this is the modified air gap line. This is the modified air gap line. So corresponding to this point on the modified air gap line, what is this point? This point is corresponding to the voltage 5174. From where we got this 5174? We got it from this calculation here. Corresponding to this 5174, we find a corresponding point in this curve. Which curve? The OCC. If you look here, this is the point corresponding to this. Now, what is the voltage here? You can find it from the graph that it is 4432. Now, if we say that here what we have said, we said that our no load voltage or excitation EMF is 5174. If we assume that, we are assuming that the machine do not have any saturation, that is, the machine do not saturate and it operates along this line. However, instead of saying that, if we say that my EF is 4432, then we take care of the saturation as well. Now, if we say that, what will be my percentage regulation? My percentage regulation four four three two minus 3600 divided by 3600 into 100. So if you calculate it like this, the result will be more near to the actual cases. We will continue our discussion in next class with a new topic.